Hello students, good morning. Today we are going to study about properties of division of integers. And in that we are going to learn about closure property under division, commutative property under division, associative property under division, distributive property under division, and identity property under division. Let us learn about all these properties. First, we will learn about closure property of integers for division. You have learned about closure property for addition of integers. In that when we add two integers, we get the sum also as an integer. Same way when we subtract two integers, the difference is also an integer. Last time we have learned when we multiply two integers, the product is also an integer. Now here we will see in case of division, when we divide two integers, do we get an integer or not? There are some examples. Let us see one by one. The first example here is -6 divided by 2. So as you know, -6 is an integer, 2 is also an integer. When you divide them, you will get quotient as 3, -3. So -3 is also an integer. Second example, -8 divided by -2. So first we'll divide 8 by 2, we'll get whole number here 4, which is also an integer. And then minus divided by minus. As you know, minus divided by minus is plus. Same like multiplication. How we get minus multiplied by minus is plus. Same way minus divided by minus is plus. So here the quotient is 4. Again it is an integer. Next example, 6 divided by -2 is equal to -3. 6 divided by 2 is 3. And plus divided by minus is minus. So -3. 8 divided by 2 is 4. Now in all these cases we are getting an integer. Now let us see this. This example. -8 divided by 4, we are getting -2. But when we are dividing -3 by -6, that means -3 will be written in the numerator and -6 is written in the denominator. So when we are dividing these two integers, we are getting here the quotient as 1/2. That means half, and half is a fraction. So can you say a fraction an integer? No. Fraction is not an integer here. 1/2 is not an integer. But if you would have written as 2/1, then you can say it is an integer. So, but here we have got answer 1/2. So, answer is not always an integer. So, this tells that when you take some integers and divide them, always we don't get an integer. So, this says that integers are not always closed under division. Now let us go ahead and see the next property. The next property is commutative property of division. For any two integers a and b, if a divided by b is equal to b divided by a, then we say that integer is said to be commutative under division. That means, for example, you take two examples in your mind. Here we have taken one example, 12 divided by 4. So a is 12 here and b is 4. So 12 divided by 4 is 3. Now if you change the order, instead of writing 12 in the numerator, you are writing 4. That means we are dividing 4 by 12. In the first case, we have divided 12 by 4. So when you divide 4 by 12, on division, we get quotient as 1 upon 3. So can you say 3 is equal to 1 upon 3? No. 3 is not equal to 1 upon 3. Therefore, integers do not satisfy commutative property under division. So here order does matter, because if you change the order, you will not get the same quotient. Now, let us go to the next slide and see. Here, you have learned about subtraction. In subtraction also, when you change the order, there is an example for subtraction also, so you can correlate with it. 8 minus 3. 8 minus 3 is how much? 5. If you change the order and if you write 3 minus 8, so 3 minus 8 will become negative 5. So 5 is not equal to minus 5. So in case of subtraction also, it is not commutative. Now when we are dividing also, you see 8 divided by 4, we are getting 2. But when we are dividing 4 by 8, we are getting half. So it means that if you change the order in a subtraction or division, you get a different answer. This tells that division is not commutative for integers. Now let us go to the next example, that is associative property. In the division of integers, the result changes when the grouping is changed. So here, when you change the grouping, you will get a different answer. So let us see with the help of example. It does not hold true for division of integers. So let us go ahead and see some examples. Now the first example is 18 divided by 6 divided by 3. Now here, and it can also be written as 18 divided by 6 divided by 3. In the first case, you can see 18 and 6 are grouped together and then they are divided. And on the other side, you can see, you can group 6 and 3 together. You can divide them first and then you can divide it with 18. Now let us start with the first side. Like first side of this, we will work out first. So 18 divided by 6 is 3. So 3 divided by 3. As you know, 3 divided by 3 is 1. Now on the other side, let us see 18 divided by 6 divided by 3. So first, as bracket is between 6 and 3, so we'll do that part first. 6 divided by 3 is 2. And then 18 divided by 2 is 9. So can you say 1 is equal to 9? No, 1 is not equal to 9. So this proves what we have told just now, that in division of integers, you will not get always the same quotient here. If you change the order, you will not get the same quotient. Now let us see another example. 100 divided by 20 divided by 5 and is equal to 100 divided by 20 divided by 5. Now you can group them in different order. On the first side you can see here 100 and 20 are grouped together and then they are divided first. And here on the other side you can see 20 is first divided by 5. And then the quotient 4 is divided by, then 100 is divided by 4. Now here let us see the first case. 100 divided by 20 is 5. And 5 divided by 5 is 1. Now here you can see 100 divided by 20 divided by 5. So 20 divided by 5 is 4. And 100 divided by 4 is 25. Now can you say 1 is equal to 25? No, 1 is not equal to 25. This tells that division is not associative for integers. Now let us see the next example. Next property. Property of the number 0. If we add or subtract 0 from any integer a, we get that integer back out. That means we have learned about it. If any integer is added or subtracted, if you add any integer by 0, you will get a. Same integer. A means the integer. And when you subtract also by 0, you will get the same integer. If we multiply any integer a by 0, we always get 0 back out. So same thing here, when a is multiplied by 0 also, we get 0. But it is impossible to divide by 0. That means if you divide any integer by 0, you will not get any proper answer. The answer will be undefined. So this shows that any integer cannot be divided by 0. Now let us go to the next slide here and see here. There is a table here. You can see here, in that there are some examples. In the first example, 0 is divided by 38. So when you write 0 in the numerator, that means when 0 is the dividend and when you divide it by any integer. So 0 divided by 38 is 0. Next example is 0 divided by minus 12 is again here 0. When you are writing any integer in the denominator and dividing it by 0, then we will get quotient as 0. So when 0 is divided by any other number except 0, the quotient is 0. Now next part you see, when any integer is divided by 0, that means when 0 is in the denominator, then the quotient is undefined. Next example, minus 7 is divided by 0 is undefined. 23 divided by 0 is undefined. That means division by 0 is undefined. There is no answer. You will not get any proper answer. But when you divide 0 by any integer, you will get quotient as 0. Now we'll go to the next property. The next property is properties of the number 1. If we multiply or divide any integer a by 1, we get that integer back out. So in the last case you have learned about multiplication of integers. When any integer is multiplied by 1, we get the same integer. Same way, when you divide any integer by 1, you will get the same integer. And this is called as properties of the number 1.